Okay, I couldn't resist. I thought I'd bring a smile to your day. So we're going to take a look at some magnet properties, little demonstrations. We're going to try to understand what's going on in this scenario. So if we take a look, here are two magnets, and if I get them close together, they are magnetically attracted to each other. Same thing with these circular magnets. These are attracted to each other as well. Okay. Now if I flip this over like this, these are still attracted to each other. However, if I flip these over, we now have a repulsion. Magnets are so fun. Okay, this is when you really can use the force. Okay, so why is that taking place? When I flip them again, they're magnetically attracted to each other. Well, you have to imagine that these guys are attracted to each other in this orientation. And if I spin them anyway this way, just like spinning these guys, they will be attracted to each other. So let's take a look and see what is going on. So we're going to do some drawing of these circular magnets. So with this, the magnetic field, these are oriented in left to right orientation. So in order to see these magnets with the left-right orientation, we have to kind of draw them in 3 dimensions. So if you can draw your circular magnet kind of like this, there's my one magnet. And the north is over here, and the south is over here. So the magnetic field lines are going around it like this. Okay, that's the magnetic field. And when you have another one that's sitting next to it, let's draw this one right here. You have the north over here and the south over here. And what you see is this. Again, the magnetic field lines will be going out from the north into the south, like this. However, what you'll also get is you'll get some of the magnetic field lines, like the electric field lines, going into the south, like this. Since these are going to be aligned, and they are aligned, they form this connection of their magnetic field lines. We make a few more going like that, a few more going like that. So again, we'll see this when we are looking at the laboratory. We'll see these magnetic field lines. However, so these are oriented in this direction here. But what happens when I turn them around like this? There's now the repulsion. So if you draw these over here, there's my one magnet. Let's say it's the north and the south. And these magnetic field lines are coming out like this. If I have another one sitting next to it, but I've spun it around so it's north and south, the magnetic field lines will go out like this. And if you remember from electric field lines do not cross. Same thing applies to here with magnetic field lines. So here we have the attraction, and here we have the repulsion. You get attraction when your fields align, your magnetic fields align. You get the repulsion when the fields don't align. Okay, so why are they attracted here versus the repelling like this? So what we have to do is we have to draw their magnetic field lines. For them to be attracted to each other, this has to be the north, and this has to be the south. So we can draw these side by side, like this. And north is going to be up, south is going to be down, and the other one will be like this. south, and then north. So the magnetic field lines are going to emanate from the north, like this, and then they will come into the south like this. We're not going to draw the whole thing. But let's actually draw the fields for these guys over here, coming out from the north, okay, coming in to the south. What's going to happen is that these magnetic field lines are going to be making a connection. Therefore, the fields align, there will be attraction. Very similar to this scenario over here, if you have your two magnets that have the same pole on the top, same poles on the bottom, what's going to happen is your magnetic field lines will go out like this, they'll go out like this, and you're going to have repulsion. They're not going to align, they're going to veer away from each other. Okay, here's where they align, here's where they don't align over here. So what I've done is I've taken a magnet, just like this, and I've taken a hammer to it and cut it like this. Actually, here's the north over here. Okay, and if you notice, the north is still aligning with this over here. And they are nicely attracted to each other. Okay, I did the same thing with this magnet right here, and you can see that I don't know if you can see the shading. This is darker, and this is like a gray. Here's a black. And I broke these two, and they're not attracted. They're actually repelling each other when they're on the same side. However, if I flip it around like this, then they're going to be attracted to each other. So again, here's the darker part, here's the lighter part. I hope you guys can see that. So what is happening here? Well, if you take a regular magnet and you break it, so let's go ahead and north and the south, and we've got these magnetic field lines and orientation of the electrons inside. They're all in the same direction. And if I break it right here, so here's a break, what's the net result going to be? The net result is going to be this. So when we break it, it's going to look like this. Oops. Going to have one broken here, put some space there. The other one will be here. Here's the south, here's the north. The electrons are oriented in this direction like this. So what happens is it creates this as being a new north and this a new south. They will each then have their own magnetic fields like this. And again, there will be this aligning of the fields in between, and they'll be attracted. But what is happening with the other one? You can draw that circular one like this, and we're going to break it here and here. So we're going to break it right down the middle. So the net result, it'll look like this. If you can draw this as best as you can, it's broken here. Oh, we lost light. So there's the one magnet, and here's the other side of the magnet. Okay, trying to draw that kind of three-dimensional. So if we had the south on the bottom And the north on the top, well, it's in the same orientation now. We have a north on the top, we have a south down below, north on the top, and a south down below. And what we have is these are each going to be generating their own magnetic fields, and you can see what's going to happen to them. They're not going to align, but they're going to repel. So that's why when you break a magnet that's circular like this, in this orientation, they're going to then repel. And of course, they will attract when their opposite poles are aligned like this. That's it. Please now go to the lab.